Okay. Okay, now hydrogen bonding. Okay. Hydrogen bonding. Hydrogen bond means it's a special type of dipole attraction. It's not separate one, right? I've given like there are 5 forces. First one is ion dipole attraction. The second one dipole attraction and hydrogen bond. Right? So hydrogen bonding is, remember, it's special type of dipole attraction. Special type means what? Okay. Positive pole should be hydrogen and negative pole should be anything. Right? Positive pole should be or must be hydrogen. Positive pole. What about negative pole? Sorry, negative pole. Negative dipole. That's what? So not negative dipole, negative pole. Right? Normally it must be fluorine, oxygen or nitrogen. Right? Okay. Most electronegative atom like fluorine, oxygen and nitrogen. Right? Not chlorine. Right? Electronegativity of nitrogen and chlorine are almost same. 3, almost same. Chlorine is little bit larger, almost same. But the dipole attraction would be much stronger for nitrogen, not for chlorine. Because size, what about size? Chlorine is large in size, nitrogen is very small. Right? We study dipole attraction and ion dipole attraction. We have studied 2 things, right? 2 attraction, ion dipole and dipole. Both these attraction strengthen with decreasing size. Right? Okay. When the size decreases, this attraction becomes very much strong. So, which atom is small in size? Chlorine or nitrogen? Nitrogen. Right? So, chlorine comes only after nitrogen. Right? Okay, here. Right? So, this should be fluorine, oxygen or nitrogen. That's called hydrogen bond. Right? Okay, that's called means so there would be a dipole attraction between this minus and plus, delta plus. That is what's that actually? Dipole attraction. But this is specially called hydrogen bonding. Right? Remember, positive pole should be hydrogen. Negative pole should be any electronegative atom, but generally these 3: fluorine, oxygen and nitrogen. Right? See? What about this? Is this attraction a hydrogen bond or normal dipole attraction? Hydrogen bond or normal dipole attraction? Normal dipole attraction, but remember this, it's also a hydrogen bond. It's also hydrogen bond, right? Okay, hydrogen and right. So hydrogen is connected to what? A bulk group like this, CCl3. CCl3. I have already mentioned hydrogen must be connected to what? Oxygen or fluorine or nitrogen. But this hydrogen is connected to a different group. That is CCl3, a different group. But it's also hydrogen bond. Right? So actually the hydrogen bond is qualitatively you can't define hydrogen bond qualitatively. How the atom would be, how the, right? That's not. Qualitatively you can't define, only quantitatively. Right? That means bond energy, how much energy you need to break this bond. Right? Normal dipole attraction actually 0.5 to 1 0.5 to 15 kilojoule per mole. Right? 0.5 to 15. But in case of hydrogen bond, 4 to 14. 4 to 40. 4 to 40. So it will be larger than the normal dipole attraction. And here it's more than 15. Right? It's more than 15. So it's also a hydrogen bond. So it's you should remember a little bit difficult to define hydrogen bond. Right? The definition should be based on what? This bond energy. Right? And here this attraction, the energy of this attraction is more than 15. I think 20, more than 24, 20, like that. So it's a strong hydrogen bond. But hydrogen is, this is compulsory. Hydrogen is compulsory to define hydrogen bond. That's why it's called hydrogen bond. Hydrogen is compulsory. But this part should be anything. But the bond energy should be very much stronger than this normal dipole. Then it is hydrogen bond. But normally it's like this. Hydrogen is connected to nitrogen, oxygen or fluorine. This is the normal condition. But there are few exceptions, only few exceptions. One is this. Right? This is one exception. And there is many more. We'll study. And then HF. HF. Let's take water. This is water molecule, right? There is no space. I'm writing it here. Water molecule. You know, in water molecule, there are two OH bond and two OH bond and two lone pairs. Right? Two lone pairs. What's the shape? Tetrahedral. Right? Molecular geometry? What? Angular. Electron pair geometry? Tetrahedral. Right? Okay. Okay. So, is this a polar molecule or non-polar molecule? Polar molecule. But the polarity is very much larger. Right? Polarity is very much larger. How? Now you can say, okay, see the resultant dipole moment. OH. Upward or downward? Downward. Why? Delta plus, what's the direction of dipole moment? Delta plus to delta minus. So downward, downward. So resultant of these two, resultant of dipole moment by these two, downward. What about these two? Lone pair. Downward, right? Delta plus delta minus, downward. So downward, downward, downward. Right? So total dipole moment will be very much larger, and its direction towards downward. Right? So water is a polar molecule, and the polarity is very much larger. So you should remember that these two lone pairs plays major role in high polarity of water. Got it? Not only these two OH group, also two lone pairs play a major role. Right? Okay. And yeah, this hydrogen. And this hydrogen. Okay. Hydrogen. You know? Right, likewise. Okay, this is hydrogen bond. Right? Okay. Yeah, hydrogen bond will be between this delta plus hydrogen and delta minus, particularly lone pair. Lone pair of delta minus. Okay. And draw these two in this gap. Hydrogen bonding.